Hey, it's me. I'm back. This is the last thing I'm going to have to say about regression. Next time, we'll jump into analysis of variance. All right. So let's take a real life example from a very large data set, high school and beyond. I am predicting math identity. So math identity is a scale where there's questions like, I see myself as a math person. Other people see me as a math person. And the predictors I'm going to use are science identity, as you might guess. That has questions on like, I see myself as a science person. I really like science. I think I'll go into science. Uh, Math achievement, which is a standardized test that was normed to a mean of 50, and then gender. And the gender was coded 1 = male, 2 = female. And this was the regression equation that I got. So I have a regression equation. It's minus 1.7. That's the intercept, plus 0.19, which is science identity, plus 0.04 times the math score, that standardized math test, plus negative zero point 0.1 times sex. Now, notice a few things here. Predictor variables, X, can be continuous or categorical, as long as you code a category as 0 or 1 or 2 or some other numeric code. That's called dummy variable coding. And I asked about that one time when I was in a statistics class when I was a graduate student, and the professor said, yes, you could dummy code it. And people kind of laughed embarrassedly because I thought he was making fun of me. But no, you can have, if you have something that's yes or no, it can be coded or male or female or whatever, one of two categories, that can be in your regression equation. And you can also have things that are continuous. Second thing to notice, the coefficient tells you the direction of the effect. So the higher the science identity, because this is positive, right? The higher the science identity, the higher you tend to score in math identity, which is your Y. The higher the math scores, the higher you tend to score in math identity. Because again, this is positive. Since sex is 1 = male, 2 = female, higher scores on sex, that is 2 versus 1, being female versus male, relate to a lower math identity. What we don't know yet is whether any of these coefficients are significantly different than 0, if our regression equation is worthless or not. We also don't know which of these predictors is most important. If you think you know at this point, based on these data, you're wrong. All right. First question, is this model any good? Now, the last video, I said that the way you got the multiple R these days is the computer gives it to you, and that's the truth. So I have a computer printout. I use SAS in this example. And the first thing it shows me is the number of records in the data set. That was 12,459. This came from the high school and beyond study. The number of those used was 12,371 because there were only data available on the dependent and independent variables for 12,371. So you could see there were only 88 that were missed. So that's not bad at all. We don't, if 90% of our data were missing, and I should tell you that in some of those studies showing the Khan Academy is so successful, 95% of the data were excluded because of missing data. So 95% of the students. So in this case, we don't need to worry about missing data. We don't need to worry about having enough in our sample. That's all good. An F value down here, an F value of 1.0 means the variance explained by this model, it's also called an F ratio, is equal to what would be expected by chance if the true value explained is 0. So we have a ratio, the amount we would expect just randomly, because probably the correlation of Y and predicted Y isn't going to be exactly 0. It might be 0.01. So anyway, an F value of 1 means this is exactly what you would expect by chance. As you can see, we have an F value of over 1,000, which is a lot more than 1. And not surprisingly, the probability of an F value this high, if all the regression coefficients are in fact 0, is very low, 0.0001. In fact, it's a lot less than 0.05, and it's also a lot less than 0.0001, but this is the lowest p-value that SAS shows. You can say you would reject the null hypothesis that none of these regression coefficients are significantly different from 0. You would not say they're all 0, but a significant F value says at least one of the regression coefficients is non-zero, but which one? It could be one predictor, it could be all of the predictors. This is why we look at the next table. And you can see here, every coefficient is significantly different from the zero, right? The probability to point zero, the intercept, we're not so interested in the intercept because that doesn't really predict anything. But science identity, the math score, sex, all of them significantly different from zero, all much less than 0.05 probability. Now, do these results mean science identity is the most important predictor just because it has the highest regression coefficient? So this is A, if you're thinking about so if you're writing out your regression equation, this would be A, this would be B1, this would be B2, don't make fun of my writing. This would be B3. And no, it does not necessarily mean science identity is the most important predictor. A regression coefficient, let's think about what it is the change in predicted Y for a 1-point change in X. However, 1 point on a math test that ranges from 20 to 80 is not the same as a 1-point change on sex with a range from 1 to 2. Standardized coefficients, also called beta weights and shown by the Greek letter beta, looks like that, predict the standard score of Y, that is the mean of 0 and a standard deviation of 1, from the standard scores of the X variables. So let's say you have an IQ score that's 15 points below its mean and an SAT score that's 200 points below its mean. Both of those would have a standard score of 1. That is, each one is 1 standard deviation below the test mean, below their respective test mean. The standardized estimate shows math score ST, which is the math score with a mean of 50. Anyway, it shows math score ST is the strongest predictor of math identity by quite a lot. So the math score is the strongest predictor, followed by science identity, and compared to actual math achievement test score or science identity, your gender is relatively much less important in predicting your math identity. And as for the multiple R squared, the computer does indeed give it to you. And as you can see here, there's the R square and it's 0.20. And so you can see why this was so significant, why the F value was so high. It says that these values explained over 20% of the variance. And explaining over 20% of the variance with over 12,000 people is very, very, very unlikely to have occurred just by chance if all of those regression coefficients were really zero. So it appears there really is a significant relationship between your identity as a math person with your math achievement, your science identity, and your gender. And the adjusted R squared, in case you wonder about that, we don't really report that often. It is the R squared adjusted for the number of variables in the model. It's usually, like in this case, pretty close to the unadjusted R squared, unless you did something really silly, like you had 10 subjects and you used 9 or 10 variables to predict. So that would be really silly. But anyway, yes, there's the R squared. There is how you get the B coefficients, the beta coefficients, the F value, all of that when you run something like SAS, when you run a multiple regression in something like SAS. So there you go.